ideas? Okay, well, when we, in division, when we're doing those division problems and we invert the fraction, we are creating a reciprocal. Okay, we're creating its reciprocal. So if I have to invert 1/3, I am now creating its reciprocal. So when I invert 1/3, what do I get? Cheyenne? 3/1. So we just created 1/3's reciprocal, 3/1. Well, here's what the mathematical definition for reciprocal is. The definition for reciprocal states that the product of a number, what does product mean? What happens when you get a product in math? What operation happens? What happens when you get a product? What operation happens? Addition, subtraction, multiplication, or division? Go ahead, class. Give it a stab. What do you think? Multiplication, yeah. So when we've got a multiplication of a number and its reciprocal, we better get 1 or they're not truly reciprocals of each other. So if 1/3 and 3/1 are reciprocal of each other, when you multiply them together, you should get 1. Okay? When you multiply them together, you should get 1. So let's do some practice here. Let's take the number 2/3 and write its reciprocal. What's its reciprocal? 3/2. We just invert it. When you invert a fraction, you've created its reciprocal. Well, now we're going to do the product of those. So we're going to take them times each other. 2/3 times 3/2. This time, let's just do the first method of multiplying, where we multiply first and then we simplify. 2 times 3 upstairs. 6. 3 times 2 downstairs. 6. Well, what's 6/6? 1. We get a product of 1. So they are reciprocals of each other. Okay, what would be the reciprocal of 4? 1/4, because how can I rewrite 4 as a fraction? 4/1. And then when we invert that, we get 1/4, don't we? So now we're going to take 4/1 times 1/4. What's 4 times 1 upstairs? 4. What's 1 times 4 downstairs? 4. And what's 4/4? 1. So if we truly have made the reciprocal correctly, when we multiply, we should get 1. Okay, why don't you try the next 2 on your own? See what happens. Try the next 2 on your own. 1/5, write its reciprocal. Multiply those 2 numbers times each other and see if you would really get 1. And then do 5/4. Okay, do we agree that the reciprocal of 1/5 is 5/1? And how would we probably most typically see that written, though, in an answer bank when they ask us for the reciprocal? What do you think they're going to do with that 5/1? It's another name for 5/1. Okay? No, not 1/5, that's its reciprocal. Cheyenne? Just 5, yeah. It's really the same as just 5. So oftentimes you will see when a whole number can be written, a fraction can be written as a whole number, that's how we're going to write it. Okay, any questions on them? Okay, what do you think the reciprocal of 1 is? 1? Well, if it is, then what should happen when we multiply 1 by its reciprocal of 1? We should get 1, do we? Yeah. So, how does that work? could write 1 as a fraction. Class? 1 over 1. Well, then if I flip that, that would be 1 over 1. It still looks the same, doesn't it? And then if I multiply those, I would get 1 times 1 upstairs, 1. 1 times 1 downstairs, 1. Sure enough, I get 1. 1 is the only number that is its own reciprocal. 1 is the only number that is its own reciprocal. And then there's only one number that does not have a reciprocal. Want to take a guess at what they think is the only number that does not have a reciprocal? 0. 0 is the only number that does not have. Because would you be able to multiply anything times 0 that would give you 1? Do you think of anything that you could multiply times 0 and you would have 1? No, so 0 does not have a reciprocal. Okay, let's go to the applied skills page that we were on before, and let's complete the bottom of that page together here, okay? So let me grab that up from, okay, so we have 3/5 times something equals 1. What do you think that would be? That something would be? 5/3. It's reciprocal. In number 2, we have 4/5 times 5/4. What should that equal? 20 over 20, which is 1. Are those reciprocals of each other? Yes, 4/5 and 5/4 are reciprocals. What do you think we would take times 2 over 1 to get 1? 1 over 2, the reciprocal of 2 over 1. Reciprocals multiplied, the product of reciprocals should be 1. Okay, number 4, what do you think we multiply times 6 to get 1? 1/6, the reciprocal of 6. What number 5? 72 over 72. Or we could just look at it and say, guess what? Those are reciprocals. What can I count on when I am multiplying reciprocals? Harley? They're going to be, the product's going to be? No, the product's going to be? Yeah, you know what? If you can identify that you have a fraction times its reciprocal, you can just go straight to 1 because we now know that a fraction or a number times its reciprocal gives you 1. It just plain old does. Okay, number 6. What should we multiply by 7 to get 1? Well, 7 over 1 is 1/7. We need its reciprocal, don't we? What do we need to multiply times 1/8 to get 1? 8 over 1, which is the same as 8, right? The whole number 8. 1/8. Reciprocal would be 8 over 1. 8 over 1 is the same as 8. Okay, 1/3 times 3 over 1. A number times its reciprocal. What's the answer? 1. 1. You can just go straight to 1. How about that last one, number 9? 1/10. We need the reciprocal of 10 over 1. It is 1/10. Okay, questions about reciprocals. Okay, then let's go back to the the bottom of the notes that we were on before. Okay, to the notes to the bottom here. Okay, factors are numbers we can multiply together Factors are parts of multiplication problems. Factors are numbers we can multiply together to get another number. So, in my example there, 2 times 3 equals 6. The 2 and the 3 are considered factors. So we're going to list all of the factors of 24, all the ways that we can get pairs of numbers to become 24. Well, a good place to start is always at 1. 1 times what is 24? 24. Does 2, let's move from 1 to 2. Does 2 go into 24? Okay, how many times does 2 go into 24? 12. So 2 times 12 is 24. So now we'll jump up to 3. Does 3 go into 24?
Yes.
Yes. Okay, so 3 is a factor. 3 times what is 24? 8. So 8 is a factor. Let's jump up to 4. Does 4 go into 24? Okay, so 4 is a factor. How many times does 4 go in? 6 times. Okay, I probably run out of spaces there because what would be the next number? 5. Does 5 go into 24? No. What's the next number? 6. Well, we already got 6 on our list, don't we? So now we can be done. We'll be done now. So we're going to put them in order. So the reason when they're not in order here is so that we can see the pairs of numbers and then we won't get lost, okay? So first in our list is going to be 1, 2, 3, 4, 6, 8, 12, 24. We don't want to leave any of them out, so let's go back and count. There were 1, 2, 3, 4, 5, 6, 7, 8 in our unordered list. So let's go 1, 2, 3, 4, 5, 6, 7, 8 in our ordered list. There are all factors of 24. This is a really important skill in math, that we can name the factors of numbers. Questions? Okay, then let's go to the back and do some practice on determining common factors. So we're going to find all the common factors of 8 and 18, because then we're going to determine what's the greatest common factor. So not the least common denominator, but this time we're looking for the greatest common factor, the biggest one they have in common. So let's list all of the factors of 8. Let's start with 1. 1 times what is 8? What times 1 is 8? 8. Okay. Does 2 go into 8? Yes. How many times? 4. 3? No. 4? Well, 4 is already there, isn't it? Okay, let's put these in order. 1, 2, 4, 8. And I want you to put it right here like this, that we don't really have 8 factors of 8. We have 4 factors of 8. Now we just put them in order. Okay, let's do 18. What should we start with? What should we start with? 18. What are the factors of 18? What should we start with? 1 and 18. 2 and 9. 2 times 9 is 18. 3 go into 18? 3, and it goes in there 6 times. 4 go into 18? No. 5 go into 18? No. 6, well, we already got 6, don't we? We get to quit. So now we'll put them in order. 1, followed by 2, followed by 3, followed by 6, followed by 9, followed by 18. In order. Because we are looking for the common factors. So we are going to circle from the ordered list, we're going to circle all the ones they have in common. So common factors, well, they both have 1s. They both have 2s. Do we have anything else in common? No, that list has a 4, but this one doesn't. That list has an 8, but that one doesn't. We've run out of options here, haven't we? So the common factors are 1 and 2. Well, the reason we did that is so we could see what is the greatest common factor for these two numbers. What is it? What's the greatest of those circled ones? 2. We would say the GCF is 2. So we're going to write right here. GCF, that's the abbreviated form of greatest common factor of 8 and 18. Those are the two numbers we were finding the greatest common factor of, is 2. The biggest number that can be divided out of both of them, basically. Okay? Questions? Okay, let's try one more then together. Find all the common factors of 16 and 48. So let's start with 16. 1 and 16. 2 and 8. 3 and 3 doesn't go in there, does it? No, I don't think so. How about 4? Okay, how many times does 4 go in there? 4. So we don't need to write another 4. We get to stop though, because you know what? That would be as well. We could still try 5, I guess. 5 go in. 6, 7, 8. 8 was already in our list. We get to stop. Put them in order. 1, 2, 4, 8, 16. In order. Let's do 48. 1 and 48. How about 2? 2 go in there? How many times? 24. How about 3? 3 go in there? Yep, it does. Yeah. No, not 3 times 8. 3 times 8 is 24. 24 is half of 48. 8 is half of 16. It goes in there 16 times. So 3 and 16 are factors. How about 4? Yes. Okay, how many times does 4 go in there? 12, okay. How about 5? No. How about 6? Yeah, how many times? 8. 8. How about 7? No. How about 8? 8's already in our list, okay? We get to now put them in order. 1. Oh, this is a long list. We better go like this as we do it. 2, 3, 4, 5, so 6, 7, so 8. What's the next smallest number after 8? No, there's a 12. Now 16, right? And then 24. And then finally 48. So there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in our original list. We have 10 in our ordered list. 2, 4, 6, 8, 10. Yes. Okay, common factors. We're going to circle. Let's start at the beginning of the list. 1. Yes. 2. 3. 4. They have to be in both lists. 6. 8. Yes. Oh, well, there's only one left in the other list. 16. Is it in the other list? Yes. Yeah, so we used up all of the one from the one list, so there can't. So now we would say these are the common factors. There are 5 common factors, but we need the what? The greatest. Which one is it? 16. So we are going to say the GCF of 16 and 48 is 16. Made it. Okay. If you did not get a chance to finish the skills maintenance, then what you're going to need to do is you're going to need to either try to get in here tonight after school so you can work on it, or if you have a study help that you can come pick it up. Remember our means of coming into my classroom and teaching and getting your workbook, and then it has to come back to it. It cannot go home with you. Your workbooks do not go home with you. If it is done,